ground fault circuit interrupter, often called a GFI, is a safety device designed to protect people from electrical shock. It does this by monitoring the current flowing in the hot and neutral wires of a circuit. If there's a difference of even a few milliamps, typically 5 milliamps, between the current going out and the current coming back, the GFI will trip, quickly cutting off the power to prevent a dangerous situation. When a GFI trips when testing hot to ground on receptacles fed from the GFI load side, but not when testing hot to neutral, a polarity reversal is the most probable cause. This means that the hot and neutral wires are swapped at one or more of the downstream receptacles connected to the GFI. This incorrect wiring can cause current to flow through the grounding path when it shouldn't, which the GFI interprets as a ground fault, causing it to trip. To troubleshoot this issue, firstly turn off the power to the circuit at the breaker. This is a crucial safety step. Secondly, verify that the GFI itself is wired correctly. The line side, which is the incoming power, should have the black or hot wire connected to the brass screw. The load side, which feeds the downstream receptacles, should have the red wire connected to the backstab connection. The white or neutral wire should be connected to the silver screw, and the green or bare wire should be connected to the green ground screw. An incorrectly wired GFI can cause all sorts of problems, including nuisance tripping. Thirdly, check the polarity of the downstream receptacles. Use a non-contact voltage tester or multimeter to confirm that the hot wire is connected to the brass screw terminal and the neutral wire is connected to the silver screw terminal at each receptacle. If you find any receptacles with reversed polarity, carefully swap the wires and the screw terminals to correct the issue. Make sure the power is off before making any wiring changes. Fifthly, after correcting any polarity reversals, turn the power back on at the breaker and retest the circuit. Use a receptacle tester or multimeter to test the hot side of the receptacles to ground again. If the GFI no longer trips, the problem has been resolved. Here are some additional considerations. If the problem persists, check for loose connections or damaged wires in the circuit. Loose connections can create resistance and cause voltage drops, which can also lead to GFI tripping. Damaged wires can create a path to ground, which will definitely cause the GFI to trip. Ensure that the downstream receptacles are properly grounded. A missing or inadequate ground can also cause the GFI to trip. If all else fails, consider replacing the GFI itself. GFI can sometimes fail, and a faulty GFI can cause nuisance tripping. Or consult with a qualified electrician to diagnose and repair the problem. When working with electricity, safety is always the top priority. If you're not comfortable working with electrical wiring, it's always best to call a professional. A multimeter is an essential tool for electrical troubleshooting. It can be used to measure voltage, current, and resistance. When checking for polarity reversals, use the multimeter to measure the voltage between the hot and neutral terminals, the hot and ground terminals, and the neutral and ground terminals. The voltage between hot and neutral should be approximately 120 volts. The voltage between hot and ground should also be approximately 120 volts, and the voltage between neutral and ground should be close to 0 volts. If the voltage readings are different, it indicates a wiring problem. A non-contact voltage tester is another useful tool for electrical troubleshooting. It can be used to detect the presence of voltage without having to make direct contact with the wires. When checking for polarity reversals, use the non-contact voltage tester to verify that the hot wire is connected to the brass screw terminal and the neutral wire is connected to the silver screw terminal. If the non-contact voltage tester indicates voltage on the neutral terminal, it indicates a polarity reversal. Understanding how GFI work and how to troubleshoot common problems can save time and money and ensure the safety of electrical systems. Remember to always follow safe electrical practices and consult with a qualified electrician when needed.